Welcome to the second session of the Avxt Insider Podcast. Today I'm joined by Justin Martin Lawrence, the Technical Manager of Avxt.
Good morning.
Thank you for your time today, Justin. So today's session is going to be about video in custom install. What are the challenges? What are some of the new and emerging technologies that we're seeing coming through? And I suppose this is the point of today is to have a bit of a tech deep dive on some of those topics, clear up some misinformation that is out there. I know it's a bit of a minefield in terms of what's myth and what's fact. Let's begin there, really. So, Justin, in your opinion, what are some of the challenges we face in video of custom install in 2022?
Well, everything's changed in all directions. So we start with the very simple concept of change with things like SkyQ, where a couple of years ago, you'd be looking at bandwidths of around 4.8 gigs. Now, with HDR10, UHD1, you're starting to head very quickly up into the 10, 11 gigs a second. And the big problem with that is, can the cabling infrastructure handle it? And specifically, can some of the extended technologies that are being used handle it? So many people have been sort of drawn into using Cat5e, maybe Cat6 for things like HDBaseT, where those cables were perfectly adequate. We're starting to see limitations simply because of the amount of bandwidth that's required, where dealers are starting to find that infrastructures that they put in a few years ago now aren't necessarily up to the bandwidth that the distribution system needs.
Okay, so are we talking about improvements to the content that Sky are pushing out in terms of what bandwidth it requires, that's breaking down, perhaps making the older cabling infrastructure, Cat5e, Cat6, as you mentioned, a bit more flaky? Because it's quite hit and miss, isn't it? With
yeah,
videos.
It is. Yeah.
You know, I hear it all the time of dealer gets called back to site because there's a video issue. Customer says he's getting dropouts, black screens for periods of time, and then it comes back. But when the dealer goes to site, it's all big thumbs up and working.
It's typical, absolutely typical. And the reason for that is because we're pushing our luck with bandwidth. First of all, there are issues with bundled cables, which perhaps we'll come on to in a bit when I talk about cabling itself. And secondly, it's simply the amount of bandwidth. You're trying to put down a cable that really is only designed for 1 gigabit per second.
Right.
So the likes of HDBaseT use clever encoding systems like pulse amplitude modulation, which enable much more bandwidth to go down the cable by using different voltage levels. But where it works very well, with lower bandwidths, you start to see problems when you start to get to the top of the HDBaseT sort of 9.8, 10 gig that HDBaseT 2 can handle. And that's some of the reason that contenders like Avxt and HDBaseT 3 have come in to improve on that. But the important thing is that now when you look at those standards, there are mandatory expectations for cabling. So for example, with Avxt, you must use a Cat6a cable because it needs to be capable of carrying 10 gigabits per second. And going back to HDBaseT 2, when you start to bundle cables and you start to have significant bandwidth running down those cables, you have a problem where you get intercable crosstalk. And then you should start looking at using screen cables, at the very least from the rack to the wall cabinet, but really trying to keep integrity all the way from the source to the destination, from the output of the matrix to the destination.
Okay, so maybe this is a good time to actually talk about some of these emerging technologies, because I'm sure there are other people out there that have a bit of a confused look on their face when you mentioned Avxt then. So everyone knows HDBaseT. It's been around a long time. HDBaseT 3, perhaps people aren't as familiar with in terms of the advantages of the next generation of HDBaseT. But what's Avxt? Where's that come from? And what does that give as an advantage to the installer?
Avxt is very exciting. It may have some limitations in its cost, but I imagine that's going to come down. It comes out of a chipset company called Semtech that used to be called Aptavision, so it was an acquisition. And they developed a chipset called Blue River NT, which was used on things like the Wirestorm NHD 600 series. And it really gave incredible image quality but over a 10 gigabit link. And the problem with that, or the limitation of that, is that it doesn't always fit the budget to have to fit a 10 gigabit network switch to be able to send that kind of quality along. So Avxt is actually, to some extent, a slimmed down version of that. It competes very, very well with HD-Base 2. In fact, it exceeds it in specification, and HD-Base T3. And what it does, the advantage that it has, is it actually uses the same packetization as 10 gig networking. So you lose the limitations of bundling cables, for example, where interference can cause issues. It also has a significant amount of bandwidth, and it's fully symmetrical, should I say, sorry. So you can actually get 10 gig in each direction, which means that you can effectively, if you ever wanted to, send a very high quality image in two directions over a single cable.
Fine, cool. So Avxt then is the new kid on the block, really. As you say, an acquisition, and is sort of, I suppose, the next generation of Blue Ribbon, but hopefully at a more affordable price point. Mm-hmm. What are some of the other advantages to Avxt? Because where HD-Base T2, where we're currently at, there are various different versions of matrices. Some go 4K to 35 meters, some go 4K to 70 meters. The way that Avxt packetizes that data, what does that give you in terms of range improvements?
Well, it's got incredible immunity. So it's as capable as a 10 gig, properly terminated 10 gig network connection over Cat6.
So we're talking 100 meters?
Cat6A, sorry. 100 meter link. You've also got the advantage that there are other signal paths that can go down it. So, for example, it fully supports EARC.
Right, which is huge.
Very important at the moment,
Yeah, okay, great. So there's some emerging technologies. Let's talk a little bit about how video has changed in the last 5 years. Before it was very much, if you wanted the utmost quality, you had to have a Blu-ray player. That was the best way to get movie content into your home theatre. But now we've obviously seen a rise of services like Disney Plus and Netflix, who are very heavily pushing on the fact that they are the latest and greatest Dolby Vision, HDR10, and the images can look fantastic. We can all agree on that. But sometimes when you scale those streams to a big multi-channel theatre like our Wisdom Room 1144, that soundtrack is a Dolby Digital Plus stream. It can sound very flat as a result. A lot of people maybe wouldn't notice, but obviously if you get used to hearing an uncompressed Dolby True HD, proper Dolby Atmos track or DTSX, when you go back to those Dolby Digital Plus streams, that is quite a big difference in quality if you A and B them. So how do we adapt to this as an industry? What technologies are there? And I know I'm bombarding you with questions here, but how do we get the best use of the quality that's coming into our homes now?
Okay, so there's been a sea change in the way things work, and one of those has been bandwidth into the home, which has enabled content delivery networks to bring in some very high quality streams into people's houses. And there's been a push for gigabit households for 2025. Companies like Virgin have actually achieved this now. Their entire customer base has access to 1 gig internet if they want it.
And there's also rise of, you see them driving around everywhere now, Hyperoptic, GigaClear, all of these companies offering fibre straight to the home. BT obviously put a big push to that as well.
Yeah.
And I think just one thing that I find is really, really important is their end goal isn't 1 gig. Their opening service is 1 gig. This isn't where they're ending, right?
Yeah,
they're absolutely pushing for 10 gigs. Some of them, I think it might even be Hyperoptic, are pushing 10 gig by 2025 for any customer that's connected right now. So that's big, right?
Yeah.
Because for the first time now, with obviously developments of Wi-Fi 6, 802.11ax, we're breaking that multi-gigabit barrier for the first time. And we're now experiencing that our internet speeds are outstripping what the network equipment is capable of inside our home, whereas before it was always, the internet speed was way slower.
Yeah, you're absolutely right. And one of the big technology pushes to try and meet this 2025 gigabit challenge has been the change from digital subscriber lines into gigabit passive optical networking,
right,
which is a very, very inexpensive and easy way to adapt a fiber to cabinet solution into a fiber to the premises, basically by using encryption and passive optical networking to get that data in. And you're absolutely right. I mean, at the moment, that's capped at 1 gig, but they're already trialing 25 gig solutions. So getting that data into the home, assuming it's available on the backbone of the country's infrastructure, would be relatively easy to do. And we're seeing, I think let's stick with the 1 gig thing at the moment. That now provides us with adequate bandwidth to get decent streams off content delivery networks, providing the right network equipment is in place.
Yeah. So and it goes back to what you were saying earlier about every link in the chain having to be right.
Yeah.
So don't want to steal your thunder, but if we're talking, let's talk about HDMI ARC versus HDMI eIRC, and because that's sort of the key piece of the puzzle, right? To moving from that compressed Dolby Digital stream to an uncompressed Dolby True HD stream, which, okay, we might not be 100% there as of today, but we've got the technology there, it's in place, it's coming, it's just a case of when they're going to implement it, right?
Yeah, absolutely. So one of the limitations, if you like, of using rigid technologies like Blu-ray HD is that obviously the hardware has to support the codecs of the time. And at the time, with Blu-ray Ultra HD, it was either H.264 in MPEG-4 containers or VC1, both of which are great codecs, but inefficient in comparison to the codecs that are used today. So you would be expecting any of the major players now to be using H.265, which is also known as ATVC. That's twice as efficient as H.264, so they can get a lot more down the pipe. And that also means that by using software platforms inside TVs, they can adapt what codecs they want to use as time goes on. And they can also adapt the quality of audio and video that comes out of it. Good example, pretty much any well-known television brand now will have an option to either output ARC or eARC. And the big difference between them is that ARC only has a limited bandwidth for the 8 channels of audio that it's going to be carrying. So without going too much down a dark technical alley, the difference between Dolby Atmos and True HD is actually not that Dolby Atmos is necessarily a different codec. It's more that Dolby Atmos can provide coordinates for True HD soundtracks to be played on multiple speakers and therefore give the effect that something is above you there, for example, rather than just around you.
Right. So it's not that Dolby Atmos is a codec, it's actually positional data.
Yes, exactly.
Right.
And of course, if you're sending compressed audio, 8 channels of compressed audio, which you would be doing with ARC, the disadvantage is you're not going to get quite the same effect as you would with an uncompressed format like eARC.
Right.
So if you take the output, let's use an example, Samsung television. If you switch a Samsung television into eARC mode, it'll actually give you 8 completely uncompressed audio streams in PCM down to your AVR. And that gives you the advantage that not only can it send the metadata for Atmos, but the actual sound itself is much, much higher quality. And it's up to the content providers whether they want to take advantage of that or not. I mean, if you read around, you'll see people that have done comparisons between PCM and Dolby Digital Plus. Everyone has said, "Oh, suddenly I can hear the heights. Suddenly I can hear the effects. It's definitely there." And there's an opportunity to make that even better as time goes on. And there are already codecs ready to go that are twice as efficient as HEVC. And why? Because most televisions you buy now are 8K. So 8K content is not going to come off a Blu-ray Ultra HD player ever. It will come off a streaming platform. Yeah. So, when people want that cinematic experience on their 5-meter screen, when it's within the content provider's hands to be able to deliver that, then obviously you're going to want the very best audio to follow with it.
So really, I suppose what we're saying is, well, the key difference I see there is that now people are, I think, and in my opinion, are less interested about video distribution and they're more interested in using a local source of the TV. Maybe that's the apps built into the TV if they like that. Or it could be a local Apple TV that they want to get back to a rack or keep the Apple TV in the rack. But they want the best quality out of that source to their system. Whereas I suppose Netflix and Disney Plus really our industry is the tiniest of niches, right? It's really small. The amount of people that have a proper high quality system to be able to appreciate that uncompressed audio stream is probably quite small to them, but it's good that with the developments of HDMI 2.1 and EARC, we're actually now able to get proper uncompressed audio, as long as every link in the chain supports it, of course, to get the best out of those systems. So that's, I suppose, ties in quite well to AVX as an example. You could use a AVX extender set to get your Apple TV 4K from your rack to your TV.
Yep.
But also you could use the extender set to get your uncompressed audio from the TV back to your receiver.
Yeah, exactly that. That's a really good example. So supposing you have got an Apple TV sited in the rack, you've got your AV processing and amplification sites in the rack. Your AV processor is presumably doing the switching, which would make the most sense. That's the perfect example, because that way you can have your television or projector, if the projector supports it, having all of that coming in, but also being able to provide uncompressed audio back.
Yeah, and that's typically what's always the problem, right? It's getting it back. So that's good. So that's an interesting development. So we've spoken a little bit about how ISPs are going to crazy gigabit speeds, and we've got the capacity and infrastructure in some places now, and for the rest of the UK, certainly on a fast rollout to get access to the new world of digital media distribution. So you mentioned specifically about Sky Glass. Mm-hmm. Now, some people are really concerned about it, others aren't. So from your point of view, what do you know of Sky Glass? How do you think it's going to affect us as an industry?
I think, as with every new technology, it's had a few bumps in the road, but they're a massive corporation. They'll sort those out. Concept of Sky Glass is difficult to fathom in the sense that, in one way, because of the way it's being marketed, it's almost being shown as a replacement for satellite-based solutions from Sky, yet they still continue to deliver Sky Q. It doesn't have the limitations, they're sort of different platforms, but in many ways it doesn't have the limitations of Sky Q. So with Sky Q, you can only have, unless you fiddle the system, you can only have one UHD box. Your mini boxes will be full HD. Yes, you can have up to 4, but you can only have 2 running consecutively. Sky Glass is a completely different concept. Everything is streamed. You need around 30 megabits per second per stream. You can have up to 3 Sky Glass televisions. You can have up to 6 Sky Glass pucks, which are like thin Apple TV size devices. And they connect either by 802.11ac wireless or Wi-Fi 5 or by Ethernet. And so you've got to consider that the sum total of that might be somewhere in the region of 270 to 300 megs once everything's up and running in every room. So you need to make sure that if you're putting that kind of thing in, you're going to have that bandwidth at home. And we cover loads of that in our networking courses. There's not really any place in the UK you can't get high-speed internet if you think about it. But you might have to do some clever tricks to get it.
Yeah.
And the whole concept of it is slightly different to Sky Q in the fact that it's recorder-less. So you stream something, you can still stream it from the beginning. This is something also Virgin are doing. So Virgin have changed their TiVo offering into Virgin 360. Principally the same thing. Different brand, different livery, but the concept's the same. In as much as when you go to watch a program, you can watch it from the beginning or you can watch it from where it's at. Qualitatively, they're very similar.
So the last thing I'd like to touch on our video edition of the podcast is HDMI 2.1. There's a lot of information out there. There's a lot of myth out there, as we get questions about it almost daily. So perhaps you could just give me a run through, give me the lowdown on HDMI 2.1. Why did it come about? What is its purpose? And what's the main user segment that can take advantage of its new features?
Well, HDMI 2 effectively ran out of steam. There's a limited amount of bandwidth, and there are all sorts of tricks being done to try and get as much as you could in that bandwidth. And ultimately, it's not going to ever be able to properly support 8K as a standard. HDMI was never designed even around 4K. Let's be honest, it was a full HD or 720p concept initially. What HDMI 2.1 does is it brings in a number of things that have slowly become standardized. So there are things like EARC, which isn't actually part of the HDMI 2.1 standard necessarily. It can come out on HDMI 2.0B products. There is finally proper support for widescreen formats. So we have 16:9 already. You have 21:9 as a standard within HDMI 2.1. You have many more refresh rate options. And that actually has been a big change because one of the ways that HDMI has worked up until HDMI 2.1 is that frame rates have to be rigid. And that's very inefficient, especially if you're looking at something that's encoding data to be decoded, because there may be points in a film or something that's going on image-wise where it's unnecessary to have that many frames per second. And there'll be other points where it's advantageous to have many more frames per second. So HDMI 2.1 brings in variable refresh rates, which is fantastic for gaming because you don't get things like image tear. You can speed up and slow down the GPU output as you please to render things better. You've got support for up to 10K video if you want it, although predominantly the focus is on 4K and 8K. There are other standards around it. Obviously, of course, it supports all the HDR formats. And I think initially, many of the things that HDMI 2.1 was designed to do might not be taken advantage of by everything. Certainly for gamers, it has a massive advantage.
So I suppose really with HDMI 2.0B, we were at the limit of its bandwidth capabilities. We were really maxing it out. So by moving to HDMI 2.1, we're now able to fit 48 gig. Am I correct? 48 gig down that pipe. So I suppose the question would be, is your HDMI 2.0B cable and your HDMI 2.1 cable look the same? So what internally has changed on that cable to allow us to go from 18 gig to 48?
Well, there's two things. So the main one is that in conventional HDMI, that's everything up to HDMI 2.0B, there were three transmission lines or pairs of transmission lines. And they used a technology called transition minimized differential signaling, which was an encoding standard, which meant that you didn't get huge variations in pulses on the cable, so that it was less susceptible to interference. And you had a clock that ran alongside that using the same twisted foil pair cable. With HDMI 2.1, it's a self-clocking format. So it uses a concept called fixed rate link, which means that spare clock pair is now available for data. So suddenly you've got an extra quarter, if you like, of pipe space for data. Then basically within FRL, they've managed to increase the speed to twice. So rather than having 6 gigabits per second per lane, they have 12. Therefore, 12 times 4 brings you 48. And the advantage of it is that it is completely backward compatible. So how an HDMI 2.1 product works is it detects if a clock's running on that fourth FRL line, and if it is, it switches back to TMDS standards. So it will fully support HDMI 2.0B right the way down to HDMI 1.0. And then when you plug in an HDMI 2.1 device, you get the extra advantages of bandwidth.
Right, okay, cool. So I suppose final question then is, now HDMI 2.1 is here, we've got 48 gig of possibility. Mm-hmm. Content, as far as I'm aware, is still pushed out, shot by and produced by the movie studios in 4K 420.
It's actually shot in 444, and it's downsampled to 420.
Okay, so we're downside to 420. So I suppose from our point of view, it's great to be able to have the capability of the hardware that we're putting in on installs it's got to have the capability to handle those signals. But unless you're at this moment in time, you've got one of the new Xboxes, one of the new PlayStation 5s that can take full advantage of that 8K, 444, 120 hertz on 4K. Yeah. It's only really in the gaming scenario that you're going to be able to tick every single box on that HDMI 2.1 standard.
Yeah, absolutely. And that's a difficult question because in broadcast, I doubt very much that'll ever change. The thing is that in movie and television broadcasts, it's imperceivable to the human eye to see a difference between 420 and 444, no matter what anybody tells you. However, when you start using text, graphics, games, it is perceivable because obviously you get that sort of color blurring, if you like, at the edge of detail. So yes, gaming, definitely 444, high frame rate, that's what everybody wants. Broadcast will generally, I should imagine, stick around the 420 and not change.
Great, so we'll leave it there. Thank you very much, Justin, for your time today. It's been very insightful. And for anyone who's not been on one of Justin's ProNet courses before, I'd highly recommend it. He covers topics from the latest and greatest on Wi-Fi 6 to a little bit more in depth on what we covered today, ISPs, and I suppose on how we can deliver proper 10 gig end-to-end networking solutions. So we would really recommend doing that. All right, thanks very much.